Hello and welcome back. Today we're going to continue our discussion of function transformations, only this time we are going to do vertical and horizontal shifts. Let's look at our sun. Right now the sun is at the point 2, 4, the x value is 2, and the y value is 4. I am going to translate my sun 7 units left. What do you think the word translated means in terms of math? So translated just means to slide or to shift. We're just going to move that sun 7 units to the left. So left is going to be that away. So I count 1, 2, 3, 4, 5, 6, 7. My new sun is right here. It's not there anymore. What are the new coordinates for that green point that's our sun? So here's how we do this. If this point is the origin, 0, 0, we count how many units to the left of the y-axis it is. So that's 1, be negative 1, negative 2, negative 3, negative 4, negative 5. So that's our x value. And fun fact, if you do a horizontal shift, meaning left or right, your y value isn't going to change because I didn't move my point, let's see right there, up or down. So the y value here was 4 and the original y value was 4, so it's still going to be 4. Just to remind you what a parent function is. A parent function is the most basic original of any type of function. Today we're going to be mostly looking at quadratic functions. That's your parabola. Just keep in mind when it's as simple as x squared, your vertex is at the origin. And we're also going to be looking at absolute value functions. Same deal. When there's no numbers around the x, your vertex is just at the origin. All of these other types of functions could come up later in math, but we're mostly going to focus on those two today. Let's look at this quadratic. You can see for x squared, our vertex is at the origin. Now I'm going to shift this quadratic over here. How can you describe the movement if your vertex was here and now all of a sudden it's here? So it looks like I shifted 3 units to the right. Now this is a little bit tricky, kind of counterintuitive, which means it's the opposite of what you might think. But if you're going to shift your function to the right, you're actually going to show that with a minus. And then the number 3 just tells you how many units. This shift is a little bit different than the up and down. When you're going left or right, you're going to have your minus or your plus inside of a set of parentheses. And to remind you, minus will be shifting to the right because you could remember there's an I in each one of those. And a plus will be to the left. Each of those has an L, but I'll have this little cheat sheet for you throughout today's lesson. Let's look at another shift. So based off of the last one, this was our quadratic. It was x minus 3 squared because we were 3 units to the right. What if I went from a vertex at this point to a vertex at that point? How can you describe this movement here? So it looks like this is 5 units left. And to show 5 units left, looks like I'm going to use a plus sign. So here's how you can write your own equation. I'm going to take my original, which is f. Oh, actually, no, they want us to use g of x. I can see right there. So g of x is, and there's 2 ways you can write it. Let's do the mathy way. I'm going to take my original x, and let's keep the color consistent. I had minus 3. And it was a squared, but because I went 5 units left, I'm going to do plus 5. I can combine the negative 3 and the positive 5, and this can be simplified to, I'm just going to carry down my original, negative 3 plus 5 is going to be whoops, and equal positive 2. And this all kind of makes sense because let's say I didn't even have my original information. My origin to my vertex is 2 units left, which is the plus 2. So you can do this a couple of ways. You could have a plus 5 in the original function, or you could do f of x plus 5 equals g of x. So we'll do a little more practice with that. I know it might seem a little complicated right now. All right, so horizontal shifts, that involves some kind of number inside of parentheses. Vertical shifts happened outside parentheses, but when you see something inside parentheses, it's going to be left or right. I kind of remember this because parentheses can like kind of look like arrows, like a left arrow and a right arrow. So if you see a number inside parentheses, that's going to be either left or right. And then you can use this little cheat sheet to tell you which direction. So it looks like we have an original parent function there, where your vertex is at the origin. So which choice would show x plus 2, keeping in mind that a plus sign means we went to the left? So that will be choice 1, because if we go twice to the left, boom, boom, we'll end up right there. You can have not only a horizontal shift, you can throw in a vertical shift. So let's take a look at our function here. My little arrows got cut off. So let's say my vertex was originally at the origin at x squared. My function went in 2 directions. Let's do the horizontal shift first, and I'll give you a hint here. It is a plus sign because we went to the left. What number should I put for the number of units I went to the left? So if you count the loops, 1, 2, 3, 4. We went 4 units left. That's what that means, 4 units left. And how else did my function move? We also went 2 units up. So I would have x plus 4 squared plus 2. That would describe my red function here, because there were 2 different movements, left and up. Here's another little cheat sheet. So if you have a number inside parentheses, that's going to be your horizontal shift. A minus sign would be right, so then the opposite of that, a plus sign, would be left. If you see a number outside of the parentheses on the end, like this one here, that is going to be your vertical shift, up or down. A plus would be up, a minus would be down. So let's use this on some examples. I'll get you started here. So our first one, x squared plus 4. Would you say that plus 4 is inside parentheses or not inside parentheses? It's not inside, I don't even see parentheses, so definitely nothing to do with parentheses. So that means I am talking about a vertical shift. If there's a plus sign, it's up. So I'm going to say up 4 units. Let's do the next one. X squared minus 5. How can you describe this shift? That is going to be down 5 units. Because there's no parentheses, so it's still a vertical shift. And if a plus sign is up, a minus sign would be down. So let's look at our next 2 examples. For x plus 6 squared, would you say that this plus 6 is inside parentheses or not inside parentheses? It's inside parentheses. So it can't be a vertical shift. It has to be a horizontal. And if it's a plus 6, do you think that's going to be to the right 6 or to the left 6? That is going to be left 6 units. Just to remind you, minus is right. Zoom in on that. And plus would have to be left. All right, I'll have you do this one. X minus 3 squared. How can you describe that shift? That would be to the right 3 units. Okay, so I'm gonna leave this cheat sheet up while we do a couple more examples. If the original function is absolute value of x, so this is gonna have two different shifts because we have two numbers here. We not only have a -7, we also have a +4. I know these don't look like parentheses, but we're gonna consider the absolute value bars to be kind of like parentheses. All right, so this first one looks a lot like my cheat sheet actually. Let's start with the -7. If you see a -7 inside parentheses, how can you describe that shift? Well, minus means right, so I'm gonna say right 7 units. And for this +4 that's outside parentheses, that's going to be a vertical shift. So how can we describe that movement? That will be up 4 units. Okay, let's do the next one. It looks like the next one is just opposite of the first one. So how can we describe the shift for x plus 8 squared in absolute value -9. So the +8, that's left. So I'm going to say left 8 units. And a -9 at the end, that means down 9 units. I'm hoping you're starting to see the difference between inside parentheses and outside parentheses. This 8 would be inside the parentheses, which are these thingies, and the 9 would be outside of parentheses. If it's inside parentheses, it's a horizontal left or right shift. If it's outside parentheses, it's a vertical up or down shift. Okay, let's do a multiple choice question. So let's say Omar graphed the function f of x equals x squared. He then graphed the function g of x equals x minus 2 squared. On the same set of the coordinate plane, the vertex is, all right, so if we just graphed x squared, I know my vertex would be right here. Actually, maybe I should color code this so that looks like it's purple. Oop. There's my purple. X squared, looks like it's right there. And then x minus 2. So let's use this cheat sheet here. Does our new function move to the left or to the right? Well, minus means to the right. So I'm going to go boop, boop, 2 units to the right. And which choice matches my new vertex? That'll be choice 3, 2 units to the right of the vertex of f of x. Okay, let's do another one. If we're given f of x equals x minus 2 squared plus 4, g of x is x minus 5 squared plus 4. When compared, what's the shift? So first of all, the only thing that's changing are the numbers inside parentheses. I started at a minus 2, and I now have a minus 5, and I don't really care about that plus 4 because it didn't really change. Okay, so if I went from a minus 2 to a minus 5, how did it shift? Okay, so if I was going to graph a minus 2, that's to the right. So I'm going to label that as f of x, and a minus 5 would be to the right. So that would be 1, 2, 3, 4, 5. Boop. And that is g of x. Okay, so how can you describe the movement from f of x to g of x, from the orange to the blue? So it looks like we went to the right 3 units. Yeah. You can also do this on a number line. If you have 0 here, -2, -3, -4. I should make that longer. -5 to go from there to there. Yep. Okay, to net graph the parabola, blah, blah, blah. We don't really care about that. We just care about where the vertex is at 2, -1. So I'm going to plot 2, -1 right here. And I'm going to label that as f of x. She then graphed the vertex of the parabola, f of x plus 3. Do you remember, if I have a plus 3 inside parentheses, is that going to be to the right or to the left? Remember, plus is left. So I go 1, 2, 3 to the left. And that would be for g of x. Ooh, that's to my parentheses, g of x. What are the coordinates for my new vertex? Well, the coordinates have to be x and y. And for this one, it looks like my x value is -1. And my y value did not change. It is still -1 as well. The graph of f of x is drawn above. Sketch the graph of f of x minus 5 on the same set of axes. If they ever ask you to sketch something on an exam, you just want to do your absolute best. They know you're not a computer and you might make some mistakes. But anyways, if we have a -5 inside parentheses, is that going to be to the left or to the right? So minus is right, so we're going to go 5 units right. Here's how you sketch on a graph. Starting with your vertex, we go 1, 2, 3, 4, 5 units to the right, and then you want to pick a couple of other points to plot just to help yourself. So maybe like this one, 1, 2, 3, 4, 5, and then I'm going to use a different color here for this point, 1, 2, 3, 4, 5. And then let's say I have a ruler. I'm going to grab my ruler and just do my absolute best. Again, not an artist. And I want to label it f of x minus 5. And this would be a 2-point question on the regions just for drawing the letter V 5 units to the right. Okay, just to remind you, our cheat sheet here, if you see a number inside parentheses, it's going to be either left or right. And if you see a number that is outside parentheses, it's going to be either up or down. All right, let's do one more. The graph of b of x is transformed using the equation b of x minus 2 minus 3. Describe how the graph of b of x changed to form the graph. This sounds way worse than it is. You don't even need this graph here. They're just asking you, what does it mean when you have a -2 inside parentheses and a -3 outside of parentheses? So again, what if you have a -2 inside parentheses and a -3 outside of parentheses? How can you describe that movement? So a -2, I'm going to draw an arrow here inside the parentheses. Remember, minus inside parentheses is to the right. So we're going to say right 2 units. And a -3 on the outside of parentheses. Well, if plus is up, minus is down. And you would get 2 points on the regions for something like this. That brings us to the end of our vertical and horizontal transformations lesson. Stay tuned for the next one. We're going to be talking about how to stretch and squeeze functions. So just let me know what you thought of this, and I'll see